Hey guys, in this video, we're gonna fine tune a CNN model, or aka a image model, aka a AI model that can recognize images and classify images. Okay, so I'm gonna do it from scratch. You're gonna need to download Pycharm because we're gonna be using files, and uploading files to Google Colab and Replit can get kind of complicated. So to just make it simple, please download Pycharm. If you don't know how to download Pycharm, um, check out earlier videos in the series. I think it's video number 4 that shows how to download Pycharm, because you're gonna need it. And make sure you download the community version because that one is free. All right. All right. Cool. Oh, and this video is part of a whole AI series, so please check out the rest of the series. Video 1 and 2 will give you a nice overview of what's going on if you're kind of lost, but you can still hop in this video and still understand what's going on. Alright, so first thing we're going to do, you guys, is we're going to make the folders for this. So when it comes to fine-tuning or training your own CNN from scratch, or training your own image model from scratch, you need to make folders, right? So I'm going to hit, I'm open up Window Explorer, and I'm just going to go to Downloads, and then I'm just going to do, I'm going to click this, New Folder, and I'm going to go inside of it, okay? Cool. So the project we're doing right now is we're going to identify damaged boxes from undamaged boxes, right? Because this is a high value situation, because e-commerce companies, or companies that ship boxes, or everyone that does like the online sales and stuff like that, one of the biggest issues that cause them to lose money or have money issues is that people will return the product if it's damaged, right? We already know, like, a lot of products every year get shipped out that are damaged, that have not maldeformities. What is the word? Wow. You get the idea. They're just not what they're supposed to be, and people get them. They're like, oh wow, this color is off. Oh my goodness, like, this is broken. Why would you send me this? And then they return it, and then they either lose, the person that sold it either lose money, or they have to now put them in the process, send them the right one, and now they get bad ratings, which is really bad, right? So this is a very big business problem. So having a system in Amazon Factory, right, that can check to see if something is actually damaged or undamaged is very, very important, because it can save them a lot of money, and two, it can increase customer satisfaction, right? So that's a big deal. So in this folder, we're gonna have one called not damaged. Oh wait, see, let's do this like this. Damaged boxed, right? They're going to make a folder called not damaged box. They're going to create a folder called not a box. Not a box. Sure, yeah, that works. Not a box, right? Cool. So this is important. So when you're training your image model for like something like this, right? A particular, very niche particular thing. Is this a damaged box? Is this not a damaged box, right? You need to also teach it what not a box is. Because if I show it something that's not a box, it's going to try to say it's a damaged box or not a damaged box, right? People always forget to add this folder in there, right? Some might call it the miscellaneous folder as well, which is a valid way to call it, a miscellaneous folder. Like everything that's not the thing you care about, essentially. Or miscellaneous can also be for random things as well, but whatever, you get the idea. So this is very important to understand. So yeah, and this is the basic flow. And then I'm going to call this folder, can I rename it from here? No, let me go back and rename it. Let's rename it Slap Jacks Box Data. Cool. Now we have this, right? So now we're going to low-key want to put this, not low-key, we're going to want to put this into Pycharm, but first let's put some images inside of it. So to do that, I'm going to use ChatGPT. So now here is how I'm going to make these box images. So I'm going to ask it, so let me make sure I explain this. I'm going to create some images using image generation, of course, but the thing is, when you save these images from ChatGPT, I ran into an issue was I couldn't train my models, or I couldn't fine tune my models using these images, which was a really big problem because of the format of the images, how they're generated. So I'm going to show a little workaround from that. So right now I'm going to type in create an image. Matter of fact, let me let it know what I'm going to do. Yeah, that would help it a lot, help it out quite a bit. Create image of a box that is very realistic. That is fully undamaged. Yeah, let's just see how that does. And I'll come back once it's done. Okay, it's doing its thing. Cool. That is a undamaged box. I would say that's a pretty good image. Let me save it right now. Okay, so now the way to turn this image into a format you can actually train your models with is you're gonna hold Windows Shift S, or pretty much want to screenshot this, right? I'm gonna screenshot or crop screenshot. If you have a Mac, you should know how to like screenshot and then crop screenshot. But I'm gonna do Windows Shift S because I have a Windows computer. I'm gonna go here. I'm gonna try not to get any black borders. I'm just gonna kind of stain like whatever this color is, this gray color is. Cool. I'm gonna click on this now. I'm gonna save it as not PNG. I'm gonna save it as a JPEG. Okay. I'm gonna put it into the Slapjocks data folder, and this is a not damaged box, right? Cool. So that's one image. So now I need like two more. This was perfect. Give me two more images that are similar but not the same. Cool. I know you have to talk to this thing like this. All right. So as this is loading, let me explain. When you're training an image model, you do not want to show it the same image too many times. You want to show it as many different variations of that image as possible. So let's say I'm taking a picture of a remote. I don't want to show the picture of the remote just like this. I want to show it at an angle, this angle, that angle, this angle. I want to show the object as many angles of the object as possible and as many images as possible, okay? You do not want to show it this side, that side, and call it a day. Because now if it sees this, it doesn't know it's a remote. You need to show it as many sides. Show it this side. You got to show all the sides of the object as possible and in different lighting. When you're training image models or fine-tuning image models, you need to make sure you show in different lighting. See, here it's very reflective, but now if I take away the light, how do I turn this light off? You know, it looks different now, right? It looks different than before. So you have this image, that's a light image. This is a non-light image or a non-bright image. So you want to show the AI model also pictures of the image when there's a lot of light or when there's not a lot of light. Okay, so you need to have that. But you can code that in. It's called data augmentation. It's a technique that you can do where you just grab. Did it make the same picture again? It made the same picture again. That's not what I want. Make the image a different angle of the box. If it struggles, I'm gonna just grab some images off of the internet. I was just trying not to use people's images to train this model because people are very sensitive about that right now. But anywho, like I was saying, so there is a way. It's called data augmentation. It's where you take the data set you already have, and you can create more data with it by adding light to them, and then creating a version of the images that don't have a lot of light. Then creating a version of the images that are rotated upside down, right? This creates more variation for the. That works. It's a different angle. It's a different angle. I'll take that. So I'm gonna take this one now. Yeah. I'm gonna save this as a JPEG, not an image box. Yes, cool. It's already gonna go into that folder. Are there other kind of now make a box image at a different angle. Yeah, make a box image at a different angle with some realistic text on it that would normally be seen on a box. Normally be seen on a box. Cool. Now, yes, so that's the, yeah, so data augmentation is a really effective way to, like, let's say you only have 5 pictures and you don't have that much time to make more. You can just do data augmentation where you get the 5 images and then you make like 5 more that are darker, 5 more that are brighter, 5 more that are upside down, 5 more that are rotated to the right slightly, and now you have, 20 images that has a high variable, right? Variability, which would help the model understand the object a lot more, or whatever it is you're trying to train it to classify. Essentially, it could be a background you want it to classify. So yeah, so that's that technique. Then you have the number of images. The more images you train or fine tune these model on, the better they will do. I'm only going to do 3, just because I don't want this video to be too long, because it does take a while to train and fine tune these models on images, because images are a lot heavier than text, right? So I'm gonna just use 3, but that's horrible. You normally you would never fine tune these things with just 3 images. I would recommend, depending on how, so the more complicated the image is, or whatever it is you're trying to classify, or yeah, whatever it is you're trying to classify, if it's complicated, you need more images. If it's simple, like red versus blue, you might not need that many images, right? But if you want to recognize this little tiny cup in the background and it's a problem or whatever, then you're going to need a lot of images for something very complex for it to understand. Or if you want to realize, I don't want to say genders. If you wanted to realize maybe ethnicity, right? Maybe people from Italy might have certain genes that pop up very commonly, and people from like Greece might have genes that pop up very commonly. But if you want to recognize these 2 different people and figure out, oh, it's someone from Greece or Italy, that's going to need a lot of data, because there are some features that might, pop up more often in the Greek and people from born and raised from Greece and born and raised from Italy, right? With people of Italian descent for years, people of Greek descent for years as well. Because you can be born there and not. Let me not get into this. I'm not trying to get in trouble. The point I'm making is, more images the better. All right, the less images. So usually, if your CNN is having trouble understanding what's going on or not classifying the way you want it, you might want to check the amount of images that you have. Okay, this image is actually really good. So I really like this one. So yeah, this is pretty nice. Cool. And peep that. And I want you guys to also notice I'm taking different screenshot sizes of the images. There's a reason why I'm doing that. I'm doing it on purpose to teach y'all something about training these kind of models, okay? So, yeah. So, okay, I have 3 in there now. That's fine for me. So, now let me do... I'm going to make like 3 more. Now, next thing I'm going to explain to you guys is image size. When you're training the images, when you're training the models on images, you're going to notice that when you're training it, you have to change the image size so that each image is the same. You can't, so I have my phone charger, right? The phone charger only accepts a certain type of plug, right? It'll be a plug, like this, right? So this plug can fit into here, right? So now that this kind of plug can't fit into this. No other plug can fit inside, right? That's how the models operate. Each image has to be the size and shape that fits into this hole. If this is the model and this is the image, all the images need to be this shape to fit inside the model, okay? For it to first to read it, to analyze, to understand anything, you have to train it on that size. So if you get images that are bigger than that, you need to shrink them down to that size. If the images are too small, you need to stretch them out. And I'm saying this because if you take a bunch of images that are really, really small and you're trying to expand it, you might lose some detail. And same thing with images that are really big. If you got to shrink them, you usually don't use a lot of detail, but maybe there's a reason why you want them that big. So just keep in mind the size of the image that you're training them on, right? Or when you're taking these pictures, right? Because if you have images that are super big and you shrink them super small and you grow them and you try to train the model on that, that's actually effective. Believe it or not, it's actually really effective, because now it'll see a really bad quality image and also a high quality image. So you actually do want to show it high quality and low quality. But if you show it a bunch of low quality images, right, to train it on, and then for the prediction, like when it's in the field, you show it a high quality image, it might not understand what it's seeing. So make sure you train the AI image model on things it will actually see in the field and things it might not see in the field, just in case, right? Because then you're going to have to go back and retrain it now on things it hasn't seen before. Try training them on as much different types of images that it might come across, right? So keep that in mind. All right. This is a nice little angle right here. I think in Apple you can use the cropping tool. Let me see. Yeah. Same image, but upside down. Upside down. Cool. I'm just keeping these images with you guys as I explain stuff that's going on. You can skip ahead if you just want to see me jump into the code. I'm just showing you everything from scratch while explaining some key details in image models, right? So the last thing I'll mention is how long these things can take. CNN models, image AI models, they can take a really long time to train if you're training it on a lot of different data, like a lot. Because what's going to happen is you need a lot of images to train it very well, and that takes time, right? And it also depends on the kind of computer you have. If you're using a computer that doesn't have a strong GPU, it's going to take a while to train the AI on images, right? So that's that point. The next point is that it's doing its thing right now. Yeah, so the next point is that just understand this is the same process as like training other LLMs, or not training LLMs, training other models. Is we have a test set and a training set. So the other reason why you need a lot of data is because when you're training a model, you need your test set and your training set. So let's say you have 100 images, you might take 20 of them for testing and 80 for training, right? So now the AI will not see even the test set, right? It will not see the test set stuff. And then you need data for validation, right? So maybe if I have 100 images for just one folder, like the not damaged boxes, I would maybe do like 50 of them for training, like maybe 75 for training. Like 50 for training, 25 for test, and 25 for validation, right? So there's 3 different data sets that I'll need potentially, right? And then now it's like now I need more images because I need to have enough images in each of the categories, right? Of training set, validation set, and test set, right? So you need to have, this is why more images are better. That's why this model is not going to do that very well. That I'm teaching you guys right now, just because even has a hole here. That's so smart. But it is kind of damaged, but you get the idea. But that's really important to point out why you need so many images. And this model is not going to do it very well. I'm just showing you how to set it up. And of course, when you have your time, you can add in more images, do your due diligence and stuff like that. All right, I think I have enough images now for this particular. How many are in this folder? How many in this folder? We got 1, 2, 3, 4, 5. Yeah, I can do like 2 training, 2 testing, 1 validation. That's what I'll do. Just so I don't waste too much time on this. All right, I'm gonna jump ahead now to make the damage boxes. Actually, let me not lose you guys. Let me show them where I'm putting these folders. So now I'm gonna go to this folder, put damage box, and I'm gonna save this into this now. Yeah, it looks crazy, but it worked for what we're going for, because this potentially could look like something realistic if they dropped a bunch of sand or glitter everywhere. So it kind of looks realistic, but we'll just keep on cooking. All right, as this is doing its thing, I'm explaining the last important point of training LLMs or fine-tuning LLMs. An issue that you might run into is that it's like the thought escaped my brain, and now I gotta go grab it to put it back in my head. So the idea is that in our current situation of technology, in our current market, it's better to just download a pre-trained image model than training a CNN from scratch, right? The reason I say this is because of performance. Performance and the amount of time it's going to take to train a CNN. To get a fresh CNN model that's empty and you're training it now from scratch on an image situation you have, it's going to take you a while potentially, depending on how complicated the situation is. And it's a lot of trial and error and guessing and figure out which, how many layers do I need, how many images do I need. There's a lot of experimenting on numbers everywhere, right? It's pretty much like a science experiment. You have to figure out, do I need more images, or do I need more variation, or do I need more neural networks, or do I need less neural networks, or do I need more neurons, or do I need less neurons, or maybe I need to increase the batch size. All these factors, you're going to have to play around on your own, trying to figure out how to get the CNN to recognize your situation properly, right? This is a really good damage box. That's nice. Okay. Cool. Right. So that's that point right there. Now, the only reason why I would say to create a CNN from scratch and train it from scratch on images, all from scratch, trying to figure out all that stuff, is if there's a particular object that you need it to recognize that pre-trained models don't recognize, right? Now, most likely it's going to be things that involve violence or things that are considered inappropriate, or most likely what you're going to have to train these things on. Because I think the pre-trained models are all like censored and guardrailed to avoid inappropriate stuff or violent things that are too violent, too graphic. I believe I could be wrong, but yeah, or security reasons, right? Maybe the thing you have never existed because it's super secret and no one knew about its existence because you're like working for the FBI or something like that. Yeah, like yeah, sure. Then that you're gonna have to train that from scratch because the thing doesn't exist, which means the model probably never seen it. And these pre-trained models, they've been trained on a lot of different things, but not everything, right? So if you're training on something very niche that no other image model recognizes, um, because it's just not a common thing. Like let's say you want to train it on a particular, like, I don't know how to explain it. Like something like this, it might not recognize what the heck this is, just because it's a very unique what do you call that? The thing that goes on the table to prevent water from whatever it's called. But this might be a little bit too niche. If you need to recognize stuff like this, you might need to train from scratch. But that's the beauty of using the pre-trained models, because you can fine-tune them, right? You can grab a pre-trained model that learned a bunch of different things and fine-tune them, and the performance is going to be way better than a CNN, a lot quicker. Okay, way less work, way less problems going on. Um, but yeah, but normally in most situations you're gonna grab a pre-trained model and you're just gonna like, yeah, you're gonna just fine tune that one on your images and it should work just fine. And I should show you guys some of the prompts I'm using so you can kind of learn prompting as well. So, but remember, this is like a whole chain I have going on. I tell it to make the text look realistic. Okay, that's very important. If you say add text, it might add some goofy text that doesn't match the image. But this is also a chain, right? This is a whole conversation going on that I've been doing. So that's why I'm giving less and less detail. I'm able to give less and less detail because my first prompt was pretty detailed, and now it just kind of remembers what I mentioned before. So I don't need to add a bunch of detail each time I talk to it in the same conversation, right? People tend to prompt engineer every single thing that they send to it, but you kind of don't have to if you did it once, and then now it kind of understands what's going on and you're good to go. But if you're doing this via code, you will need to prompt engineer every single response going in, because most, if you're coding an AI, if you're sending a prompt via code, like using the API and stuff like that, you're gonna have to do it every time. You're gonna have to prompt engineer every single time, because usually they're one-shot systems, right? It just goes once, it doesn't remember what you said last time. And there's a way you can, there's a way around that we might go over later in the series. But yeah, there's a technique where you can AI prompt engineer and have it remember the conversation it's been having the whole time. But we'll get into that into a different video, okay? But yes, so long story short, training on CNN from scratch is probably not the best practice. It takes a lot of time, a lot of effort. Grabbing a pre-trained model and just fine-tuning that is probably your best bet for the best performance. And there's different sizes and things of that nature. So that's pretty much the last point. Oh, actually, no. And for data augmentation, you can also change the tint, like the color tint of an image. You can put like a slight light red layer over it, or a slight, sorry, my shoulder cracked, a slight light blue layer over it, right? That adds more data augmentation layers if you need to add that, right? But yeah, that's pretty much, that came out UPS ground. That's actually really good. That's really good. Okay, we should be almost done with this. I'm just showing you guys a lot of the process so you guys don't feel lost and confused on how I did certain stuff. And I just need one more image. I'm gonna tell you to make it upside down. Same image, but upside down and with different text that looks realistic. Yeah, cool. So I'm gonna let that do its thing. All right, now I'm gonna add a bunch of images that are just oh, that's the damage box screenshots. I'm gonna add a bunch of images that I know are not, yeah, like these screenshots. I'm gonna grab like a bunch of these. Copy, these are screenshots from my YouTube channel. I have two different YouTube channels. So where is it? Yeah, and I'm gonna put this into that box. I'm not gonna show you what they are. Don't worry about what these images are. But yes. So that's pretty much what I did. So you can just go to ChatGPT and have it create random images like apples, right? You can be like, oh, make me an image of an apple. And then you can use like random images from here to add to your folder, essentially, right? I'm not gonna give you these images in the link that I normally give you guys the code in. Actually, no, I lied. I'll give you guys images. I'm just not gonna put anything inside not a box. You gonna fill up not a matter of fact, fine. I'll fill up not a box for you guys. I'll be I'll do that extra mile for you. So yeah, that way when you run the code, it works out the box. You don't have to do all this prep work I'm doing. But I only did it just and showed you guys because I want to explain the key components of training a CNN slash image classifier model, because other model types can also do it besides CNNs. It's just they're the most notoriously known for doing it really well. And now we have things like there's a lot of different kind of model types now. CNN is just like the original OG model that was really good at classifying image models. But I'm going to move on now to adding this into my Pycharm. So I'm going to open up Pycharm, and how do I explain it? So I'm going to right click this. I'm going to go to Open in Explorer. When I learned about this, where did it go? What in the world? Hold on. What in the world? Why is it not popping up? Hold on, I might need to close all these. 1 second. Because it's confusing me now. Why are you not opening? There we go. It opened up. Okay. Cool. So now this is the folder where all my files are in. Yeah, cool. So I'm opening up another one just to make it super easy on you guys so you guys can see it happening. This is my Pycharm file, right? Or Pycharm folder, or some call it a directory because they want to sound fancy. No disrespect, I'm just joking. Cool. So now I'm gonna add this into that. So I'm gonna add this folder. I'm gonna right click, copy, hold Control, press V, or you can right click and paste, whichever you feel like doing. So now this folder is gonna show y'all. It's funny. This folder is inside of my project folder. So when I close this, poof, it popped up. So now you can check it out here as well, right? Cool. Should be all JPEGs. No, those are PNGs. Oh, you definitely have to. Oh yeah, when you train these things, you have to keep track of the file types, right? I got JPEGs, JPG files, and I got PNG files. So I need to make sure my code includes that it can see JPG files and PNG files. Cool. Now on to the coding parts. All right, so first we're gonna pip install. So we're gonna come here, right there. Matter of fact, let me make this bigger for you guys. File settings, make the font a lot bigger. Where's the font? Editor, font. Let's do font like, let's do like 20. All right, cool, nice, cool. So now we're gonna do pip install torch, and then torch vision. Pretty sure that's how it's spelled. Cool. So we're gonna pip install those first, because we're gonna need those libraries. And then we should be good to start cooking. And remember, once you're done pip installing, to let this load right here at the bottom of Pycharm. So that way it works properly. If not, it's probably not gonna even let you run the code, to be honest with you. Cool. I'm gonna let that do its thing for a bit. Here's that apple from earlier. But you guys are gonna need to download the GPU version. Pretty much we're gonna download something called CUDA, C-U-D-A, and we need that if we're gonna access our GPU for training. Otherwise, it's gonna take a really long time to train this model, right? So I'll show you how to get it. So we're gonna type in CUDA install. I have NVIDIA. So we're gonna go here. I'm not doing any of that. I have a Windows computer. Is it a 64? I'm pretty sure my Windows 10. Yeah, 1 sec. So the way to know is to type in here system information. I'm on Windows 10, by the way. And look for system type. It says 64 base PC. Most PCs should be 64, but yeah, so it is 64, and I'm pretty sure I have Windows 10. Yeah, this is not the 11. Thank goodness. And then we'll do a local download, and now we're gonna download this CUDA toolkit installer. Okay. Just so y'all see, it's downloading right here. I know it's blocking it with my big head. Cool. It's done downloading. I'm gonna open this up. I want to show you guys what happens. Is it opening? Where did it go? What the heck? What is going on? It's probably taking a while to load. 1 sec. There it is. I was just being impatient. My bad. Just want to give you all the best quality video, you know what I'm saying? Alright, anywho, yeah, sure. Okay, cool. So now it's gonna do its thing. It's gonna download. Yeah, keep in mind it's gonna take some time, so be a little patient. I mean, in the meantime, you could be generating some images that you could be using, but I'm joking. I mean, which you probably could. So you should see this pop up at some point. Sorry, this process takes a little bit of time. I'm trying to show you the in-between steps. Let me explain what CUDA actually does. So CUDA, I think I explained it earlier, but CUDA unlocks your GPU so that it's able to be used to train AI models on it, right? Because when you train on GPU, it trains a lot faster than on CPU. Okay. So then you'll see something like this pop up. But CUDA is most like if you're trying to program, right? If you're not programming, you probably won't need to download CUDA, but depends on some software you might want to use. But normally, it's mostly if you're trying to make your own models or fine tune your own models on your local PC, then you'll need to download CUDA. Agree. I didn't read any terms. Express recommended. Yeah, we'll do that. Express. Please cause all apps on flashing might occur during installation. Oh snap. This may or may not stop my video from recording. Yeah, now that I remember, if I run this, it's gonna stop the video that I'm recording. Alright, I had to ask ChatGPT real quick. So I should be fine because I'm using OBS. So I'm gonna just let it do its thing. I just know when I've done it before on my other PC, yeah, it shut down everything. Or like my screen started flickering and stuff like that. So yeah. But let me just pause my video just in case anything happens. But it will stop the recording if I update my drivers, but don't update your drivers if you're doing something in particular. I would recommend you do this early in the morning so that you don't mess up anything else you're doing or downloading because it might stop them.